In this section, we'll begin to study a larger family of trigonometric equations, and we'll introduce how to solve these equations using identities. We've seen before that algebra can be used to solve a good number of trig equations, but using identities are going to allow us to make these equations simpler. Let's work an example, and here we want to find the exact solutions of the following trig equation over the interval 0 to 2 pi. Notice first, on the left-hand side of this equation, we can use the difference formula for cosine. Rewriting this, we'll get that this is then equal to a cosine of cosine of x minus 2x is equal to the cubed root divided by 2. Simplifying this now, this is the cosine of a negative x is equal to the cubed root divided by 2. Then we can go ahead and form our right triangles. We know that our cosine needs to be positive in quad 1 and also quad 4. Then our right triangle is going to have adjacent side length square root of 3 and hypotenuse 2. And it's going to have an opposite side length of 1. The angle then of triangle 1 is given by pi divided by 6. And the reference angle of triangle 2 here is also given by pi divided by 6, which means that our other value, let's call this theta prime, is going to be equal to 2 pi minus pi divided by 6. Simplifying this, we're going to get that this is equal to an 11 pi divided by 6. And these are going to be our two solutions for this equation on the interval between 0 and 2 pi. Let's continue to look at some more examples. Here, we're going to solve the equation cosine of 2 theta is equal to cosine theta using the double angle formula. And recall that we have three different choices of expressions for the double angle formula of a cosine. These choices are given by the following. And what we're going to do is we'll choose the double angle identity involving only the cosine here. So rewriting the left-hand side, we'll get 2 cosine squared x minus 1 is equal to cosine theta. Now subtract the cosine theta on both sides. This becomes a 2 cosine squared x. Oops. I just realized I'm writing the wrong variable. So this should be a theta here, and we should have a theta here. So 2 cosine squared theta minus cosine theta minus 1 is equal to 0. And again, we see that this is in the form of a polynomial. So let's go ahead and factor this. Factoring this out, we get a 2 cosine theta plus 1 times a cosine theta minus 1 is still equal to 0. And now we have two separate trig equations to solve. And we'll go ahead and do this one at a time. So our 2 cosine theta plus 1 is equal to 0. Can be rewritten to say cosine of theta is equal to a negative 1/2. Then again, our cosine theta is only negative in quad 2 and quad 3, which means we want to form a right triangle in quadrant 2 with adjacent side length of negative 1, hypotenuse 2. And we want to form a right triangle in the third quadrant, again with adjacent side negative 1 and hypotenuse 2. Then in both cases here, this gives us the third side is the square root of 3. And the reference angle for both of these, we'll call it theta bar. Again, this is the reference angle. And this is going to be pi divided by 3. Then to find the corresponding angles, we'll call one theta 1. Then theta 1 is going to be found by taking pi minus our reference angle. And this leaves us with 2 pi divided by 3. Then theta 2 is found by taking pi and adding our reference angle. And this leaves us with a 4 pi divided by 3. So we found our two particular solutions to this equation here. And to find the general ones, we just add a 2 pi k to each solution. So the solutions that we're going to get for our cosine theta is equal to a negative 1/2 are going to be given by theta is equal to a 4 pi divided by 3 plus a 2 pi k. And also the other solution is going to be given by a 2 pi divided by 3 plus 2 pi k. So we're halfway done with this problem. We need to go ahead now and find the solutions for the other equation that we had, which was cosine of theta minus 1 is equal to 0. So we have our cosine theta minus 1 is equal to 0. Then our cosine theta is equal to 1. And cosine of theta is equal to 1 on only one spot. And that's given by when our angle is 0. Then one particular solution that we have is theta is equal to 0. So every other solution for this trig identity is going to be given by 0 plus some multiple of 2 pi. Therefore, we found all solutions to this trig equation. Let's look at one more example. Let's go ahead and solve the following equation for theta between the angles of 0 and 2 pi, but not including 2 pi. First, we'll rewrite this equation. This gives us a 3 cosine theta plus 3 is equal to a 2 sine squared theta. And what we want to do is we want to rewrite the equation so that everything's in terms of cosine. Recall that we have our Pythagorean identity given by cosine squared theta plus sine squared theta is equal to 1. And we're going to replace our sine squared theta with a 1 minus cosine squared theta. And now we're going to go ahead and multiply this out and then write everything on the left-hand side. This is going to give us a 3 cosine theta plus 3 is equal to a 2 minus 2 cosine squared theta. Then this becomes a 2 cosine squared theta minus 3 cosine theta plus 1. Again, let's go ahead and factor this. This is going to be equal to a 2 cosine theta plus 1 times a cosine theta plus 1. And again, we have two different equations to solve. We have this 2 cosine theta plus 1 and this cosine theta plus 1. So in our first equation of our 2 cosine theta plus 1 is equal to 0, this is equivalent to the same thing as cosine theta is equal to a negative 1/2. And we saw in the previous problem that we had general solutions. Theta is equal to a 2 pi divided by 3 plus a 2 pi times k. And we also had another solution of a 4 pi divided by 3 plus our 2 pi times k. And remember, we're only looking for theta values between 0 and 2 pi, but not including 2 pi. This means the solutions we're looking for this equation are given by 2 pi divided by 3 and 4 pi divided by 3. So this is the solutions to this given equation here. Now let's go ahead and find the solutions to our other equation. In the other case, we had a cosine theta plus 1 is equal to 0, or equivalently, our cosine theta is going to be equal to a negative 1. So there's a few different ways that we can solve this, but again, remember, we're only looking at theta values between 0 and 2 pi. So if we wanted to go ahead and draw our graph, the graph of our function would look something like this, and we only have one value that makes this a negative 1. And writing this as a unit circle, then the only value that makes our cosine a negative 1 is this angle here. Oops, sorry, that's sine. We want cosine. Therefore, this theta angle here is going to be equal to pi. So our solutions then to our original equation are given by three different numbers: 2 pi divided by 3, 4 pi divided by 3, and also pi.